Greetings. This is Team A's project for BIDA640. The team members include Ankur Bata, Melanie Appleton, Matthew Rogers, and Rashid Ocean. Here is our agenda. First, we'll start off with the objective of our project. Then we'll introduce you to the meaning of our project, the purpose. Then we'll go into the methodology, the different methods we used for our project to determine this information. We'll go into the data collection and preparation. Then we'll go into the different programs we use to conduct this project, which is SAS, JMP Pro, and Excel's that tools. And we'll go into the results and the conclusion. Our objective was to take school data from grade schools in the 51 states for a 10-year period, using the different data mining techniques and models to predict students' enrollment, the total revenue and expenditure, as well as the total pass out for the students for the upcoming year, which would be 2016, using that collective data. We wanted to eventually, our outcome would be determining the variance between the actual data for each state. There are various reasons for an accurate budget, mainly to predict overall or future costs. This info was collected for years and has been collected for years and made available for the public. We decided to go ahead and explore this data with the attempt to determine variance. Data mining and predictive analytics can assist in identifying problems, preparing, exploring, and transforming data, as well as assist with building, validating, and employing analytical models, and then evaluating that and monitoring the result. Business processes are mostly time-stamped, which happens to be a marriage of forecasting and traditional data mining technique. It uses time dimensions and predictive analytics to improve the decision-making process. So our report compared time series data using SAS Data Miner, JMP Pro, and Excel. As stated before, we looked at time series forecasting. We did this by using SAS Enterprise Miner, JMP Pro, and Excel Stat Tools. Using these different methods helped us compare and determine which method would be best for forecasting the revenue, enrollment, expenditure, and grades for this data. First, we collected the data from Kaggle, then prepared it using the 3 programs mentioned for analysis and forecasting. We then evaluated the results. We found our data set on Kaggle, which consisted of 51 variables of 50 states plus Washington, D.C. And it also included 1,493 records from 92 to 2017. The data included a lot of information about the students from various things like grade, race, state, and the scores. We also retrieved the info from government records, the Census Bureau, and the National Center for Education Statistics. After we discussed many options to go through to predict or make this project about, we decided to look at revenue, expenditures, enrollment numbers for grade school students. And then we determined which trends stood out in the data and use that to predict the revenue, expenditure, and enrollment for 2016 in each state.
Hello everyone, I'm Ankur Bagda, and in this presentation I'm going to explain how we did the data preparation, data analysis, and used SAS Enterprise Miner tool for time series analysis and time series forecasting. We got our raw data from Kaggle. The initial data had 193 variables and 1492 records. This data was from year 1992 to 2017. After analyzing this raw data, we decided to do the forecasting for number of students enrolled, school's revenue, school's expenditure, and the student's grade for year 2016. And for this period, we decided to consider the 20 years worth of data from 1996 to 2015. 2016 actual values also we have. So we thought to predict the values for 2016 and compare them with the actual values. So the raw file was like this, which had 193 variables and these records. So we removed all redundant variables and records. Our final clean file looked like this. We imported this clean file into our SAS Enterprise Miner by file import node. Once the file was imported, we analyzed the data by using the time series data preparation node. For this presentation, we thought to consider total revenue. So once the file is imported, we considered only the total revenue, and other forecasting fields we decided as no. We defined these properties. So when we ran this data preparation node analysis results, we see that SAS Enterprise Miner created 51 time series, one time series for each state for total revenue. It also compared each time series with other time series, and it also gave us a plot chart. So you can see the total revenue of California is highest, and after California it is New York and then Texas. After this initial data analysis, we considered the TS similarity node. This node compares all time series with each other and gave us a distance map. So in this distance map matrix, you can see that blue color shows the time series are similar to each other and red shows they are dissimilar. It also gave us a cluster constellation plot for each time series. After this analysis of all 51 time series, we decided to do analysis of each time series with other 51 time series based on the targets. So we use a metadata node. In this metadata node, we selected two time series, that is time series 2 and time series 3. Time series 2 is Alaska, time series 3 is Arizona. And to this metadata node, we connected a TS similarity node and run this analysis. The result of this analysis showed us each time series with the best 5 other time series match. So the first plot shows the time series 2 had a good match with had a similarity with the time series of Idaho, that is time series 13. Similarly, the time series 2 has a similar plot as of time series 51, that is of Wyoming. It also gave us the block chart of 5 time series which are similar to each other. It also gave us a distance map between the 2 time series which we selected. Blue shows similar, red shows dissimilar. After this the initial analysis of the data and all the time series, we decided to move forward to do the forecasting. For forecasting, we will use the exponential smoothing node. After selecting the exponential smoothing node for total revenue, we decided to have these values. So if I go to SAS Enterprise Miner and do this the exponential smoothing node, we decided to have this value like interval as year, forecasting method as the best, and the best forecasting method selection is the mean square method. When I click here, you can see there are various different methods which we can use for the forecasting. We decided to go with the best, that is the capability of the SAS Enterprise Miner. So once we ran this, we got the result out of exponential smoothing node, the predictions. So if you can see here for Alabama, we got a predicted value of 7255611. This is one layout. SAS Enterprise Miner can give us another layouts like this and this. It also gives us various other details about the forecasting, like forecast summary, plot, forecast histogram, and the comparison plot. That's all I have for SAS Enterprise Data Miner. I'll pass control to Rashid to explain us SAS Jump Pro. Thank you all.
With SAS Jump Pro, you can do a lot of problem solving. As the Jump Pro was developed by a company called SAS, and in this portion, we're trying to use SAS for some of these predictive analysis. With SAS Jump, you can solve problems, reveal opportunities, and inform decisions to enrich comprehensive and capable statistic analysis. Such statistical analysis include univariate and multivariate linear and nonlinear analysis, ANOVA, MANOVA, and cover, time series, multivariate optimization, Monte Carlo simulation, hierarchical, and K-clustering. With this, you can do a lot of stuff using SAS. So we decided to use SAS Jump Pro to check for some of the predictive model do the forecasting as well as time series. So decided to use that which we think will give us a good information at the end of the day. This is an example of what we did. We use SAS JumPro for time series analysis. On this portion, we decided to use moving average to predict what is going to be for all the state. Each state was analyzed with SAS, giving different portion. On this slide, we have three different forms. We have a three moving average, 4 moving average, and 5 moving average. As you can see on this slide, each of them is kind of very similar. But on this portion, you can see that we now compare all the three different moving average that we use on this portion, so that this one can give us the best opportunity to find most definite predictive analysis of those. From this, the moving average seems to produce the best and the most quality prediction for the analysis. On this slide, this is using JumPro forecast. This is for one state, Alabama. If you can look at the three on the right side, there are three columns, three colors. One on the red, two blues, upper blue and lower blue. If you look at it, the red in the middle is the better predictor for all this the state from the year 2016 to 2023 or 2036. If you look at it on the right side, it takes the line of the best fit, that particular one, and it shows on the right side that it's actually very good predictor for this exercise. On this graph, this portion of the slide, we decided to add a little bit of Excel pivot table to find the relationship between the average enrollment for each of the state for the overall time, the average of the graduating student, the total revenue that was generated by each of the states, and also total expenditure for each of the states. As you can see on the slide, the revenue and the expenditure are kind of very, very similar nature. Also, if you look at the enrollment and the number of graduates that was produced in each of the state, it shows there's a relationship between the enrollment and the number of graduates, as well as the total average revenue for each of the state and the average total expenditure of the state. The two graphs, the average expenditure and the average revenue, they were overlapping, as well as the enrollment number of graduates. This shows that they correlated and they are going on the same trend. The higher the expenditure, the higher the revenue, and the number of students that are actually coming in is translating to the number of students that are actually graduating from the schools.
Hello, my name is Matt, and in this section of the presentation, we'll be talking about Microsoft Excel. In particular, we'll be talking about StatTool, which is an add-in to Microsoft Excel, which integrates completely with the spreadsheet. It replaces Excel's built-in statistics functions with its own calculations. For this project, we employed moving average forecasting and time series graphs. Now, StatTool isn't necessarily as powerful as some of the other tools that can be used for forecasting. However, it was one that we ended up using for our project. In Microsoft Excel, we arranged the data based on per state total revenue from 1996 to 2015. From there, we determined the moving average based on the previous 3 years and tried to predict total revenues per state for the year 2016. We then created a time series graph using the stat tool add-in in Microsoft Excel to compare and visualize total revenue per state in Washington, D.C. for the years 1996 through 2015, and including the forecast based on the moving average of the previous 3 years for 2016. Now, unfortunately, because Stat Tools isn't powerful as other applications, it only allows 10 variables per graph, and we had to create 6 separate graphs in order to show a time series for all 50 states plus Washington, D.C. In this slide, you'll see the first 2 time series graphs we were able to generate using the Stat Tool add-in in Microsoft Excel. If you look at the first time series graph, you'll notice there are 2 lines, the red and the blue, that are a little bit higher than the other lines. These are representative of the 2 states, California and Florida, and this makes sense that they'd have more total revenue since they have a higher population. If you look at the second graph, you'll see that there are as well 3 other lines that are higher than the other ones, and these also are representative for the total revenue for the more populated states of Illinois, Georgia, and Indiana. Because of the limited power of the Stat Tool add-in, we were unable to include total revenue for all 50 states or Washington, D.C. on one graph. Because of this, we had to generate 6 separate graphs. We arranged the total revenue per state alphabetically and batched them in variables of 10 per graph. This is the maximum allowed in Stat Tools. This slide shows the next 2 time series graphs we were able to generate. This slide contains the last 2 time series graphs we were able to generate using the Stat Tool add-in. Graph on the left has the total revenue on 10 states. And then, of course, we had 1 left over, and that is what is apparent on the graph on the right, which would be the total revenue for years 1996 through 2015, and, of course, our forecasted 2016. This table shows the actual total revenue per state for 2016 as compared to what we predicted total revenue was going to be based on the moving average of the previous 3 years for 2016. And of course, the difference between those 2 numbers. You'll notice that District of Columbia had the closest forecast with a difference of only $11,793, and California had the widest with over $16 million as a difference.
So in conclusion, by taking the data from the 50 states plus Washington, D.C. from the years 1996 to 2015 and using 2016 as the validation year from the data set we received off of Kaggle, we were able to forecast future expenditure, enrollment numbers, and revenue. This was done using SAS Data Miner, SAS Jump Pro, and Excel with the Stat Tool add-in. After we receive our professor feedback, we will then deliver our results. So I want to take the opportunity to thank you for watching our presentation, and we hope you enjoyed it.